In my opinion, one of the finest British radios ever made was the Hacker Herald and Sovereign range from the 60s, made in Maidenhead, using very high quality components, beautifully built, very expensive set. This is the Herald RP30, and this is a medium and long wave radio only. As a child, my parents were given one of these for their wedding, one of their wedding presents, and I remember it well, listening to it on the long wave, listening to Radio 4. I bought this one as a spares or repair, and it's actually in a lot better condition than I actually thought when I actually bought it. I thought it was going to be a bit of an old dog, but it's actually really pretty nice nick. It's been sitting in the car, so it's a bit it's a bit damp at the moment, where it's just brought it into the warm. They're always renowned for their sound quality. Not so much this version, but the RP35, I think it is, and the 38, is it? There's a VHF only Herald, and the Sovereign and Sovereign 2 versions were all very good. This is yeah, just long wave, medium wave only. The Hacker brothers were very keen on how good the sound quality was. They were very interested in fidelity and wanted an amplifier that would sound high quality amplifier. It's a proper push-pull output stage, and this is the amplifier board with adjustments for bias and DC offset. Basically the DC offset pot, you set the, well, it's not DC offset, sorry, it's amplifier balance. It would be DC offset if it was a directly coupled amplifier with a split rail. And what it does is it makes sure that both of the transistors get equal drive. So what you do in this particular radio is you set the bias voltage on one of the bias transistors, and that should give you equal drive on each state of the amplifier. The other way you can do it is to drive the amplifier to clipping and adjust it for symmetrical clipping. The IF stage is here. The tuning section is all up the top. This is the tune and the capacitor tuner and the trimmers for the tuner. It's got a nice large Goodman's speaker, with quite a 16 ohm speaker, produces good volume from a, I think it's a 1.5 watt amplifier. The IF 2-stage IF here, maybe 3-stage IF. I'm not sure. Can't remember from the. I've got a manual somewhere. That's your local oscillator coil sitting at the top there. This is the first, second IF, and I think this is the final IF. They do need recapping generally, as they're getting on to sort of 50 years old now. A lot of the capacitors will have dried up, but there are a few that will still work absolutely fine. It really depends on how well they've been looked after and if they've been stored in a sort of like a warm place. This one looks like it's been stored in quite a damp area, so I wouldn't be surprised if this one is probably okay capacitor wise. There's a couple that look a bit dodgy. Looks like there's a detector diode there maybe, but it does suffer from the unfortunately the AF117 syndrome, and also, as you can see from this rusty hinge, if the batteries are left in there for more than sort of like 4 or 5 years, they'll start to leak and spew their acid all over the place. Well, this isn't the end of the world. I can clean that hinge up, and I might only use this as spares, so I've got a couple of these anyway. But the dial's in really nice nick, so it's well worth having a look at to see what it's like. So it uses 2 PP9 batteries wired in series to give 18 volts. I haven't got any PP9s at the moment, so I'm going to run it off an external supply. So we're going to power it up and see if we get any signs of life at all, and if we don't, we'll try and get the set to work. So I'll plug it into the power supply, which is on, and turn it on, see what happens. First of all, there's a slight increase in power consumption, which shows something, but it's pretty dead at the moment. Let's amplify. Sounds like this. Okay, so we've got a bad connection on this capacitor here. The current consumption started to go up, so that's a bad sign. Checking the output stage isn't getting hot. It could be that capacitor's leaky actually, and that's putting this DC on the speakers. Let's just see if you can feel DC on the speaker. Yeah, speaker's gone DC. basically what that means is this is the final output capacitor, and it's gone short. So what's happening is it starts sticking DC current straight through the output stage. So the first thing we need to do is to get that capacitor changed. I can tell it's making DC, but I don't know if you can see, but if you can see the speaker cone here, if I reconnect that capacitor, you'll see that the speaker cone moves out. See that? That means that there's a direct current going through the speaker. That's going to burn the amplifier out, and it's not going to do the speaker any good. So the first thing we'll do is we'll turn it off, and we'll remove this amplifier for further investigation. Now, the lovely thing about these radios, they're lovely, really easy to work on, and the amplifier section, as you see here, just unbolts quite simply with a couple of nuts. These nuts look like possibly been replaced, because they used to have like a little nylon screw-on sleeve that used to hold these in place. So they were easier, like a little thumb wheel to undo. So we remove that. Remove this multi-pin connector. Let's get it out of the radio first. Okay, and remove this multi-way connector and the speaker terminals there, and there, and get this capacitor out. So what's happened with this capacitor, as you see, it's broken off the board by the looks of it. It's actually fractured clean off. So let's remove this capacitor, and it looks like someone's been in here as well to do some repairs. There's a bit of solder splash underneath. I doubt it would have gone out of the factory like that. As I say, Hacker are very pernickety about how their workmanship. They wouldn't have let anything like that go out, I wouldn't have thought. Get this cap out. And there we go. Now what is this? This is an old TCC, so it's a 12 volt at 500 microfarads. So that'll be replaced with a 470. Now this is as this is an audio coupling capacitor, we don't want to go much lower than 470, because you'll start to get the low frequency bass roll off. It does look like it's had a couple of these capacitors changed, but we'll try them anyway and see how they do. These things, there's another one that's broken, as you see, or it's about to break away from the board. These things are awful. These are Dally caps. I've never known either of these last. But we'll change this capacitor first, and we'll see if we get any improvement in audio. So let's find for the time being, I'll find a capacitor just to stick in there. So we need a 470 microfarad. So we'll just pop in there, and then we'll see what happens. So go from my box of bits. 680, that would work. Physically a bit big, probably a bit high voltage for what we need. And modern capacitors are so much smaller, they always look a bit strange when you put them onto the board. To be honest with you, it doesn't matter if we go up to sort of like 1000 micro. There's a 470, 450. Let's try that. These are reasonably good quality capacitors. They'll certainly last longer than the original capacitor did. Let's remove the track from the board. Let's clean up the solder. There's our other hole, there it is. Okay, let's stick that cap in there, preserving polarity obviously. Okay, so what we'll do is we'll solder this in, and then we'll power it up again and see what it does, see if there's any signs of any life at all. And what I'll do is, if this radio is viable, I'll rewire this amplifier, recap this amplifier totally. As I always recommend with these old Hackers, these capacitors will have failed, and certainly they're not leaky. they're going to be high, very high ESR, and you're going to be losing a lot of audio through them. So let's plug this back in. Reconnect the speakers. Okay. Now when you're careful with them, you put them down, because obviously there's that metal hinge there. You don't want to short the thing out and destroy all your hard work. Positive connection. Let's just plug that back in where it's meant to be, so it's not going to flop about and short something out. Yeah, cool.
This is O.J. Simpson.
Quite impressive, really, for a radio that's been sitting around so long. I'm surprised the AF117s haven't failed, but
with me to talk
clearly
about
works.
This, Historian Amanda Vickery, the writer and novelist Natalie Haynes, and the writer Jim.
That's a classic sign of a leaky capacitor. I know it can also be a noisy pot, but adjusting that volume control is a sign that one of the caps is very leaky. So, as I said, we'll change that.
Halfway between Sicily and the Tunisian coastline.
Current consumption is normal.
At the beginning of A Bigger Splash, a place of refuge for Marianne and Paul.
So the set's working fine on long wave.
As a 3 and behind it.
Sounds a bit thin, so yeah, definitely going to need a cap replacement on the amplifier board. But it's working, which is surprising, and it doesn't sound like the Tin Whiskers problem is a problem. Oh, I spoke too soon. There you go. Tin Whiskers in that AF117. Let's try this one down here. Yep. Okay, this one's pretty got Tin Whiskers, so we can zap that if that's going to cause a problem. But what I'll do is the next stage I'll recap the amplifier board, and then we'll move on to the checking of those AF117s and just checking general alignment. Anyway,